Hi guys, in today's video we're going to have a look at the most recent Pure Math 3 exam from October-November 2022 series. Before we start, please note that at this moment there is no mark scheme available for this paper, so I might make a few mistakes along the way, and if I do, please let me know in the comments section. It will help a lot other students who are watching this video. And with that being said, let's have a look at the first question. Alright, to begin with, let's take natural log of both sides. And now we can apply laws of logs. I'm going to use these two. Using the first rule, on the left side we will get 3x minus 1 times natural log 2. And using the second rule, on the right side we will get natural log 5 plus log 3 to the power of 1 minus x. And now we can use the first rule again to this log. And now I will expand the bracket. Now, our goal is to find x, so I will combine everything with x on the left side, basically these two terms, and everything without x will go to the right side. Now, I will factorize the left side and take x outside. And I will combine all the logs on the right side, using again the second rule, but only from right to left. So the sum of logs can be combined as the log of a product. So that will be natural log of 5 times 3 times 2. That will be 30. And now to find x, I will divide both sides of the equation by the bracket, and I will get x equals to natural log 30 over 3 log 2 plus log 3. And now I will have to simplify a little bit further. 3 log 2 can be written as natural log of 2 to the power of 3, which is 8, plus natural log 3. And then at the bottom we have the sum of logs, so that means we can write it as log of a product. 8 times 3 is 24. Here we go, this is going to be our answer. Question 2 is about the factor theorem. So first of all, I'm going to make the factor equals to 0. And now I will solve it for x. So x will be minus 3 over 2. And now, according to the factor theorem, when I substitute that number into the polynomial, the result should be equal to 0. So let's do that. And p of negative 3 over 2, 2 times negative 3 over 2, minus negative 3 over 2 squared, plus a, and that should be equal to 0. Okay, let's simplify that, and this part will give us minus 9 plus a equals to 0, so a equals to 9. Moving on. Okay, in question B we will have to solve the inequality. Our polynomial is less than 0, so first let's write it down. Now we know that 2x plus 3 is the factor of our polynomial, so that means we can divide it by 2x plus 3. To start with, I will have to multiply 2x by x squared, so I can get 2x cubed. And when I multiply, I will get 2x cubed plus 3x squared. Now subtract. We'll get minus 4x squared plus 9. Now I will have to multiply 2x by negative 2x, so I can get negative 4x squared. And when I do so, I will get negative 4x squared minus 6x. Subtract, and we'll get 6x plus 9. And at this point, I will have to multiply 2x by 3, so I can get 6x. When I multiply, I will get 6x plus 9, subtract, and the remainder is 0. So that means our inequality can be written as 2x plus 3 times x squared minus 2x plus 3 less than 0. And to begin with, I will try to solve the equation 2x plus 3 times x squared minus 2x plus 3 equals to 0. Split it into 2. 2x plus 3 equals to 0, or x squared minus 2x plus 3 equals to 0. And if you try to solve this equation using the quadratic formula, you will find out that it has no solutions, because b squared minus 4ac will be equal to 4 minus 12, which is less than 0, so it has no solutions. And if you think about it graphically, then the graph is a quadratic function, it opens up, and it has no intersection with x-axis because the equation has no solutions. So that means x squared minus 2x plus 3 is always positive. And looking back to our inequality, we'll get 2x plus 3 multiplied by x squared minus 2x plus 3 less than 0. And as we've just shown, this bracket is always positive. So that means I can just divide by the bracket, and no need to change the inequality sign because the bracket is positive. And that is just a simple linear inequality, so x is less than negative 3 over 2. Question 3 is about differentiation and finding the stationary point, and to do so we'll have to find the derivative and make it equals to 0. In our function we have a product of sine x and sine 2x, so let's use the product rule for differentiation. That will be u derivative v plus v derivative u. Derivative of sine is cosine times sine 2x. That's my u derivative v. Now find v derivative, and we have to use the chain rule. Derivative of the outside is going to be cosine 2x times derivative of the inside, which is 2. And then we multiply by u, which is sine x. And we're going to make it equals to 0 and solve for x. To start with, I will replace sine 2x with the double angle formula, which is 2 sine x cosine x. And that gives me 2 sine x cosine squared x plus, just copy 2 cos 2x sine x. Next, factorize and take 2 sine x out of the bracket. The product equals to 0 when one of the factors is 0. So 2 sine x equals to 0. That's an easy one. So x equals to 0, or we can always find a second solution for sine by doing pi or 180 degrees minus the first one. So that's just pi. For the second one, I will use the double angle formula for cosine, 2 cosine squared x minus 1. So all in all, we got 3 cosine squared x minus 1 equals to 0. Take the square root and don't forget about two values, plus or minus. And now find the inverse cosine of both, and we'll get x equals to 0.9553. And for cosine, we can do 2 pi minus the first value. And for this one, we'll get 2.19. And again, 2 pi minus the first one will give us 4.1. Now our answer should be in between 0 and pi over 2. Pi over 2 will be approximately 1.5, so only this solution works. Okay, next question is quite standard, and to start with, I will have to factorize and factor out the square root of a squared plus b squared, where a and b are the numbers next to cosine and sine. And that is going to be 4 squared 16 and minus 1 squared is 1. Add them up and we'll get 17. So that's what I got, and now look at this formula. Compound angle, and you can find it in the formula sheet if you don't remember. Now compare this to our result. Here we got cosine x, so cosine alpha should be equal to 4 over square root of 17. Take the inverse cosine and we'll get alpha equals to 14.04. And now we'll have to use it to solve the equation. So now let's replace our left side with the result from the previous question, and notice that we have 2x instead of just x. Divide both sides by square root of 17. And take the inverse cosine. (43.314). And then right after taking the inverse cosine, we will do 360 degrees minus the first result, which is 316.686. And now we can add 360 degrees to both of the answers. So we'll get 2x plus 14.04 equals to 676.686. And now add 360 to the first one. (403.314). And now we can solve each of the equations. basically minus 14.04 and then divided by 2. And then we're going to keep only the first two, because they are in a range from 0 to 180. Maybe let's round to 2 decimal places. Okay, next question about complex numbers, and we have to solve the equation and give the answers in the form x plus iy. So let's say this is going to be number z, and we can put it back into the equation. Let's open the brackets. And notice how I get minus y squared. That's because I squared equals to negative 1. Multiply out this bracket. So get minus 6xi. And then I will get minus 6i times iy. And again, this guy, I times I, will be negative 1. So all in all, I will get plus. And then minus 12 equals to 0. Now I want to combine together the real part and the imaginary part. So let me highlight the imaginary part. And then for the imaginary part, I will factorize and take I out of the bracket. Now the left side should be equals to 0. And that can happen only if the real part is 0 and the imaginary part is also 0. So that brings us to simultaneous equations. This second equation looks much easier because I can factorize it, and that's exactly what I'm going to do. And that splits into x equals to 0, or y minus 3 equals to 0, so y equals to 3. And now let's go back into the first equation, and then if x equals to 0, basically substitute 0 in there, we'll get minus y squared plus 6y minus 12 equals to 0. I just want to multiply by minus 1. And let's solve it using the quadratic formula. B squared 36 minus 4ac is going to be minus 48. Oops, that is less than 0. So that means we have no solutions. Now let's go to the second case. If y equals to 3. Substitute 3 into the equation, we'll get x squared minus 9 plus 18 minus 12 equals to 0. That brings us to x squared minus 3 equals to 0. So x squared is 3, and x would be plus or minus square root of 3. Here we go, the answer is going to be square root of 3 plus 3i, or negative root 3 plus 3i. Agar diagram comes next. Let's look at the first number. Square root of 3 is the real part, and it's about 1.7, so somewhere here, and 3 is the imaginary part. So the point is somewhere here, so it's A, and now pretty much the same for the other number. Ta-da! Find the exact modulus and argument of each root. We're going to use this formula for finding the modulus. Let's write down our numbers. Think of a positive square root, and square it is going to be 3. 3 squared is going to be 9. So all in all, we got 12. And actually the same is for the negative square root of 3. So it's also square root of 12. Now let's find the argument. And for that, let's consider this little triangle. That's the angle we're looking for. 3 and square root of 3. Remember SOHCAHTOA. We can use tangent. And because we're looking for the angle, we have to use the inverse tangent. So opposite over adjacent. And that is pi over 3. And now the same stuff for number b. This little angle here will be pi over 3. So that means the angle on top, this one, will be pi over 2 minus pi over 3. So it's pi over 6. And all in all, argument b is going to be pi over 2, or 90 degrees, plus our angle on top, which is pi over 6. Four pi over 6, which is 2 pi over 3. And now we have to show that triangle OAB is equilateral. We already know the length of OA and the length of OB, that's square root of 12. And now all we have to do is to find the length AB. Now look at the diagram. The length of AB is going to be square root of 3 plus another square root of 3, which is 2 square root of 3. Now we can always write the square root of 12 as the square root of 4 times 3, and the square root of 4 is 2. So we've got 2 times square root of 3. Now all the sides of the triangle are equal. Therefore it is equilateral. For the question about vectors, it's always a good idea to draw a diagram. Your diagram doesn't have to be precise or accurate. All we care about is the relationship or the relative position of the points. Okay, so that's vector OA, OB, and OC. Now we're looking for the angle BAC. And when you use the scalar product, the direction of those vectors is going to be important. So the vectors should be either pointing out of the point, or they should be both pointing in a point. So either like this, or like that. This will not be correct. So let's draw both of the vectors out of point A. Now, by looking at the picture, we can see that we're going to need vector AB and a vector AC. So let's find it. We can find vector AB as the vector OB minus vector OA. 2, minus 2, 1. And the vector AC is going to be OC minus OA. 5, 3 minus 2. Take away 1, 3, 1. That will be 4, 0, negative 3. Now let's remember the formula for a scalar product. A dot B equals to the magnitude of A times the magnitude of B times cosine of the angle in between. Or you can find it using the coordinates x times x plus y times y plus z times z. Alright, let's calculate the magnitude of the first vector. That was AB. And that's going to be the square root of 2 squared is 4, minus 2 is 4 again, 1 squared is 1. So it's the square root of 9 or 3. And vector AC will give us the square root of 16 plus 0 plus 9. It's the square root of 25, or that equals to 5. Okay, now let's substitute that into the formula. 3 times 5 times cosine theta. And now let's use the dot product using the coordinates. Use these two vectors. X times x, or 2 times 4 is 8. Minus 2 times 0 is 0. And then 1 times negative 3 is negative 3. So 15 cosine theta equals to 5. Divide both sides by 5. And there we go, cosine theta equals to a third. Okay, and hence we'll have to find the area of the triangle ABC. Again, let's draw the picture. We already know the magnitude of AB and AC. That's 3 and 5. And for the area, I'm going to use the formula a half AB sine C. And C should be the angle in between A and B. So basically that angle. Maybe let's call it theta instead of C, just to be a bit more consistent. Okay, from the previous question, we already know the cosine of the angle. That was a third. And to find sine of the angle, we could use probably the most famous trigonometric identity. Then take the square root, so it's going to be square root of 8 over 9, square root of 8 over 3, and substitute that in our formula. All in all, I got 5 square root of 2. Next one, differential equations, and for the first one, we'll only have to differentiate cotangent squared theta. For that, I'm going to use the chain rule. Derivative of the outside to cotangent theta times derivative of cotangent. And we may assume that it equals to minus cosecant squared theta. And what is cosecant? It's 1 over sine. That is exactly what we had to show. And now it's time to solve the differential equation. Let me copy the equation first. And for that, we're going to use a technique called variable separation. If you're not sure what it is, have a look at another video explaining this technique. But now I will proceed and just multiply both sides by d theta. Now here my goal is to separate the variables, so that means everything with x should be on the left side, including dx, and everything on the right should only have theta. So that means I'll divide both sides by sine squared theta. Okay, this step our variables are separated, so that means we can integrate both sides. Now the integral on the left is easy, it's going to be just x squared over 2. For this one, we will have to simplify the fraction a little bit. Now, tangent squared would be sine squared over cosine squared. And then instead of writing sine squared like that, and building multiple fractions, I will replace the fraction line with the division sign. Now, how do I divide fractions? Just multiply by the reciprocal or flip it over and replace division by multiplication. So that will be 1 over sine squared. And now that simplifies to 1 over cosine squared. And now 1 over cosine, that is secant. And now the integral of secant squared, you can find it in the formula sheet, is going to be tangent theta. And at this point, I think we're good to go, and we'll start our actual integration. The one on the left will be x squared over 2. The integral of secant squared is tangent theta. And now this guy looks suspiciously familiar. Now in this question we've shown the derivative of cotangent squared will be minus 2 cotangent theta over sine squared theta. And if you think of integration as the opposite of differentiation, you might notice that the integral of the fraction should be equal to cotangent squared theta. And now don't forget the c. Now, how do we find c? Let's have a look at the question one more time. It is given that x equals to 2 and theta is pi over 4. So let's substitute this into the equation. Two squared is 4, divided by 2 is 2. Tangent pi over 4 is 1, and so is cotangent. Therefore c equals to 0. Now we have to find the value of x when theta equals to pi over 6. Now we're going to substitute this into our solution, and we'll get x squared over 2 equals to tangent pi over 6 plus cotangent squared of pi over 6, and now we know that c equals to 0. And that brings us to x squared over 2 equals to 3.57735, and when we solve it, by multiplying by 2 and taking the square root, we'll get x equals to 2.67. Alright, next one we'll have to find point A, and that happens when y coordinate equals to 0. So that means we could do sine square root of x equals to 0. Take the inverse sign and we'll get 0. Or you can always do pi minus the first solution for sine. So it's just pi, square both, and we'll get x equals to 0, or x equals to pi squared. And by looking at the graph, we can obviously see that a is not 0, but it should be equal to pi squared. Okay, now we'll have to integrate by substitution to find the area under the curve. Our integral is going to look like integral from 0 to pi squared sine square root of x dx. First, let's recalculate the limits. U equals to square root of x. So if x equals to 0, then u is also 0. And when x equals to pi squared, u is going to be just pi. For the next step, let's replace dx with du. And for that, we'll have to differentiate our formula for the substitution. Du over dx. And I'm going to write the square root as the power. And now I use the power rule for differentiation. Put the power in front and then subtract 1 from the power. And I can write it as 1 over 2 square root of x. Now consider this equation and cross-multiply it. And that's our replacement for dx, but let's not forget that square root of x is u, so 2u du is equal to dx. Now, finally, let's rewrite our integral in terms of u. Limits are from 0 to pi. Instead of square root of x, we have u, and instead of dx, we've got 2u du. Now let's take the constant out of the integral. And now we have to integrate that. Now, when you have to integrate the product of something, chances are that you'll have to use integration by parts. Let's take the formula for this first. And normally it's given in terms of u and v, but we already have u in our integration, so let's just replace it with like f and g. So the integral of f derivative g should be equal to fg minus the integral and switch the derivative. So g derivative f. Now we'll have to decide what's going to be f derivative and what is going to be g. Start thinking with g. You will have to differentiate it, and ideally the result should be easier than g itself. I think the good candidate would be g equals to u. Therefore, f derivative should be equals to sine u. So to find the f, we will have to integrate. Integral of sine is going to be minus cosine. And g derivative is going to be just 1. And now let's rewrite our integral. F times g. That's going to be minus u cosine u. Minus the integral g derivative times f. And the limits are from 0 to pi. Now, minus and minus will be plus. The integral of cosine is going to be sine. And our limits are from 0 to pi. Now substitute the upper limit and when I substitute the lower limit I will get 0. Now cosine pi is -1 and sine pi is 0. That means all in all I got 2 pi. Okay, next question. We know that the area of the segment should be equal to the third of the area of a semicircle. And this is going to be our starting point for getting this equation. To begin with, the area of a semicircle is going to be pi r squared over 2. Now the area of the segment is going to be the area of the sector AOC minus the area of a triangle AOC. Now to find the area of the sector, we'll have to know that angle. And because r is the radius, that means we have an isosceles triangle. So this angle here is theta. And angles in a triangle add up to pi radians or 180 degrees. So this angle here will be pi minus 2 theta. Now the area of the sector is going to be r squared over 2 times the angle, which is pi minus 2 theta, minus the area of a triangle. And for that I will use the formula half AB times sine C. So it's a half. Radius times radius will be radius squared times sine of the angle. And this should be equal to a third of the area of a semicircle. So that guy divided by 3. Now divide both sides by r squared and multiply by 2 to get rid of these 2's. That's going to be 3. So all in all we got pi minus 2 theta minus sine pi minus 2 theta equals to pi over 3. Now let's rearrange this a little bit. And use the formula for the compound angle. Sine pi is 0. Cosine pi is -1. And we can also take the negative sign out of the sine function, because sine minus x equals to minus sine x. And then minus and minus will eventually give us a plus. Now let's subtract pi from both sides. We get minus 2 pi over 3. And divide by -2. Now look at what we are supposed to get. A third should be outside. So inside we'll get pi minus 3 over 2 sine 2 theta. And of course 3 over 2 is 1.5. So that's what we are supposed to get. Now for the next question, I'm going to substitute 0.5 and 0.7 into our previous equation and see what happens. So if theta equals to 0.5, I will get 0.5 equals to 103 pi minus 3 over 2 times sine 2 times 0.5 is 1. Calculate this, and actually that gives us 0.63. So 0.5 is in fact less than 0.63. Substitute 0.7. Calculate and get 0.55. Now this time 0.7 is bigger than 0.55. So when we substitute 0.5 in our equation, we'll see that left side is smaller than the right side. When I substitute 0.7, we get that the left side is bigger than the right side. So that means somewhere in between of 0.5 and 0.7, the left side will be equal to the right side. And I will state this as a conclusion. The change of the inequality sign indicates the presence of the root on the interval. Next one, we'll have to use the iterative formula. So let's write it down. Theta n plus 1 equals to a third pi minus 1.5 sine 2 theta n. Draw a table. And to start with, choose any number between 0.5 and 0.7, let's say 0.6, and substitute this into our formula. I will get 0.58118 and repeat the process. Now 0.58118 becomes our new theta n, and the result will be 0.58833. And now repeat the process until you get the answer correct to 3 decimal places. And now if we look at this result, correct to 3 decimal places, that's the same number. That means we're done. Okay, question 10 is about partial fractions. And to do that, we'll have to look at the denominator. First, we have a linear factor, and that will bring us to a over 1 plus x. Now, the second bracket is the unfactorizable quadratics. And this will be bx plus c over 2 plus x squared. Now combine these two fractions into one. Now the two fractions, the one at the beginning and the one I just written, should be the same for any x. So I will consider only the numerators of both fractions And then I will substitute some convenient numbers into the left and the right side and see what happens. So first of all, I will substitute x equals to -1, so I can get rid of this bracket. When I substitute -1 into 4 minus x plus x squared, I will get 6. Substitute it to our fractions with a, b, and c, and get 3a. So therefore a equals to 2. Now what else can I substitute? Let's say 0, so I can get rid of b. Substitute to the initial fraction, we got 4. Substitute to our fractions with a, b, and c, and we'll get 2a plus c. And now we know that a equals to 2. So we'll get 4 equals to 4 plus c. So c equals to 0. And now I'm going to substitute x equals to 1. I will get 4 equals to a times 3 plus b, and c is 0, times 2. We know that a equals to 2, so get 4 equals to 6 plus 2b. Minus 2 equals to 2b, so b equals to -1. And now finally substitute all of that into here. And we will get 2 over 1 plus x minus x over x squared plus 2. And now we have to use our partial fractions for integration. The first one is going to be quite easy. It's just 2 times log 1 plus x. And now for the first one, and now for the second one, we will have to use the formula, the integral of f derivative over f equals to natural log f. Now notice that in that formula, the bottom part of the fraction is f. So let's differentiate x squared plus 2. And that equals to 2x, which is almost the same as x, but apart from the 2. So what I'm going to do is I will sneak in 2 in the numerator, but in order not to change the fraction, I will put 1 over 2 in front. And now I can use that formula. So all in all, we got 2 times natural log 1 plus x minus a half natural log x squared plus 2. And the limits are from 0 to 4. So got 2 times natural log 5 minus 1 over 2 natural log 18. Now substitute 0 and take it with a negative sign. Now log 1 is 0. Minus a minus in those brackets will give us a plus. And I will have to use a couple of laws of logs. So bring the number in front of the log into the power. So 5 squared is 25 minus log 18, and then power of 1 over 2 will be a square root. And the same stuff here. And now we can combine into a single log. So when you're adding logs, that means it's going to be a log of the product. And when you're subtracting, that's a log of a fraction. Yeah, it's division. So all in all, we get natural log 25 times square root of 2 over square root of 18. Now let us simplify a bit further. Under the square root, we'll get 9, and the square root of 9 is 3. So here we go, that's the simplified version of the answer. Okay, and that was the last question of this paper. Once again, there is no mark scheme yet for this paper, so if you're watching this video and you spotted some mistakes, please leave a comment. That will help other people who are watching this. Also, let me know what you think of this paper. Do you think it was more difficult, or was it a bit easier than other papers? And last but not least, I really want to say a huge thank you to the student who sent me questions from this exam. I'm not sure if you're watching this, but if you do, thank you. I do appreciate it. Alright, and that's it for this video. I will see you next time. Bye.